Greetings, my name is Robert Kane. Welcome to Variables in PowerShell. In this video, we'll be going in depth with PowerShell variables. We'll start with a basic overview, then look at the cmdlets PowerShell uses for variables. The string variable type is quite powerful, so we'll have a detailed discussion on it. Arrays are also supported in PowerShell, as are hash tables, and we'll go over both of these before wrapping things up with a look at the built-in variables. In PowerShell, all variables start with a $sign. Here I have a variable called hi, and I'm going to assign it the value hello world. Now if I want to print out what's in that variable, I can simply put that variable name on a line by itself. And there I have it return hello world. Now this is really just a little syntactic sugar. What PowerShell understands is that you actually meant to write this variable out to the host, so it shortcuts it by automatically filling in the write host command for us. I could have actually just called the write host cmdlet and passed in the name of the variable, and I get the same results. It's important to understand that all variables within PowerShell, indeed pretty much everything in PowerShell, is a .NET type of some kind. Here, if I call the getType method on my variable, it tells me that it's a string, which makes sense because we put the value hello world into it. Unlike some languages, PowerShell is mutable variables, so I can reassign it the value 5, and when I run this, the type will now have changed to an integer. And sure enough, I'm now holding an int32 as a high variable instead of a moment ago when I had a string. It is possible to declare your variables in a statically typed fashion. Here, I'm going to use the .NET type of system.int32 to force my variable myInt to be an integer. If I do a getType, you can see I've printed out the value is 42, and it is indeed an int. The difference now is if I try to assign a string into this integer, it produces an error for me because I've statically typed this to be an int32. It will not mutate into anything else. While I had to type in system.int32, there are actually shortcuts within PowerShell for most of the .NET data types. Here you can see I'm using just the word int, which equates to an int32. I also have the option of a string and several other data types including short, float, decimal, and so forth. It's important to realize that not just variables, but many things in PowerShell are .NET data types. Here I've just put the value of 42 and called its getType, and you can see it becomes an int. I can do the same thing with a static string, and it comes back as a string. Now what this means is we can call any of the methods on a .NET string data type. For example, I can come down here and call the toUpper method, and you can see down in my output I now have Pluralsight rocks in caps. I can also come here and I can see if it contains the word Pluralsight, and it does return true, so we know it does. PowerShell handles its comparisons in a slightly different manner than most programming languages. Here I'm going to assign a value of 42 to my variable. That done, I want to do some comparisons. Most languages use things like less than, greater than, even the equal sign, but PowerShell reserves these for special functions. Even the equal is used for doing assignments. So what does PowerShell use? Well, it adapted a syntax that somewhat reminds me of a URL when you're passing in values, such as GT, LT, and so forth. It uses a -GT to do a greater than comparison. If I compare the value 40 to what's in my variable, it tells me it's true because 42 is greater than 40. For the same token, if I do a less than comparison, it returns false because 42 is not less than 40. And of course it uses -EQ for equals. And there's a whole list of them down here. We have equals, not equal to, less than, greater than, less than or equal to, or greater than or equal to. We also have some comparisons for strings. We have like, not like, match, and no match. Next, we'll take a look at calculations, and there's not a whole lot to show here because calculations are pretty much like they are in any other language. For example, I can use the asterisk to multiply 3 by 11 and return the value of 33. The other standard operators like plus, minus, and slash apply to do addition, subtraction, and division. PowerShell also supports the unary operators of plus plus and minus minus. If I take the value of var, which is 33 currently, and I plus plus it, I now get 34 on my output. Because of its typing system, you have to be careful of implicit type conversions within PowerShell. For example, if I compare the string 42 to the numeric 42, they come out equal because PowerShell converts 42 from an int to a string. And likewise, when I do it this way, it'll convert it from a string to an int and come out true on comparison. The rule is whatever is on the right side of the comparison operator is converted to the data type on the left. Now this can lead to some odd conversions when you're doing the comparisons. Let's take a look at this next line. It's going to take the string value of 042 and it's going to convert that to an integer, so it can compare it to the integer type of 42 over on the left. Well, when it does so, the leading 0 goes away and you just wind up with the numeric value 42, and your comparison comes out to be true. On the next line, however, we're going to be converting the integer value 42 into a string. When it does so, the resulting string will be just quote 42 quote, which will not compare equally to the 042 that's on the left, and it's going to come back false. So just be careful when you're doing some of these conversions and comparisons, and don't trust too much on implicit type conversions. In our lesson on variables so far, you've seen variable usage. It's pretty much like any other language. If we want to assign the value of 33 to a variable, we simply say the variable equals 33, and then we can print it back out. Text works very similarly. What you have to understand though is, under the scenes, PowerShell is calling one of 5 commandlets for you. It's worth knowing about these variable commandlets, so let's take a look at them. The first one is new variable. Through new variable, we assign the value of a variable. What you see here, new variable -name var -value equals 123, is the equivalent of saying $var equals 123. And we'll print it back out. And you can see, sure enough, we have 123 now held in our variable. Note that for the variable commandlets, you don't use the $sign when you're passing them into the variable commandlet. If we want to take a value out of the variable and display it, we can use get-variable, the variable name, and then pass in the parameter -value only. This will emulate what you saw above where we simply put $var. If we hadn't passed in the value of -value only, we would display both the name and the value in formatted output. If I want to see all of the variables, both user-defined and system-defined, I can simply say get-variable. And you can see here we get a list of all of our variables that are out here, including our -var right there. Okay. We can also assign a new value to an existing variable. This is the equivalent of $var equals 789. Instead, we'll use set variable -name var -value 789, and we'll print it out. And there we go. Our existing variable now has a new value to it. So far, what you've seen is pretty easy to do using the existing variable commands that you know about. A couple of nifty things, though, you can do that you can't do normally through variables is you can clear the contents of a variable, the equivalent of setting it to a null value. So here, I'm going to use clear variable -name, and it will clear the contents. Now if I display it, you can see it doesn't display anything. If I were to come back up here and use my get-variable command, you see it does display the variable. It's still there, it just doesn't have anything in it. If, however, I come down here and I use the remove variable command, remove variable completely obliterates that variable from memory. It no longer exists in the context of the current PowerShell environment. So when I run this, now if I were to come try to get the value, it would actually generate an error because that variable no longer exists. Not only will it produce the error for get variable, it'll also do so for clear variable or remove variable. Note, if I had just tried to do a $var and run that, it actually works because the minute I do that, it actually creates a new version of the variable. So be aware that if once you remove a variable, if at any point you try to reference it again, that variable pops back into existence. PowerShell is one of the most versatile languages for dealing with strings that I've ever seen. You can define strings using double quotation marks and single quotation marks. In order to embed quotes within another quote, we can mix them. Here, I want hello world to be surrounded by double quotes, so we'll embed them in a string defined by single quotes. And we can see hello world is properly quoted. The reverse holds true. Here I want can't to have a single quote, so I'll embed the whole string in double quotes. And you can see my single quote comes through. If we don't want to mix quotes, we can use a technique called double quoting to embed quotes within other quotes. Here I have double quote, hello world, double quote, and can define the string with double quotation marks. And here you can see hello world comes out correctly. And the same holds true for the single quotes. I have single quote for can't. And there it is. As with many languages, PowerShell allows you to embed special characters within the strings. These special characters are denoted using escape sequences. Escape sequences begin with a backtick, which is the little key next to the number 1 on your keyboard, and it's usually the unshifted version of the little tilde squiggly character. Here, the backspace can be represented with a backtick B. Unfortunately, it doesn't show up well within the shell, so we actually need to open up a PowerShell window. And here you can see I've got plural, backtick B, and cite. And when I hit enter, I actually get cite as my results. Another special character that's often used is the new line character. As you can see, backtick in forces the remaining of the word onto a new line. Another one you'll see often is the carriage return. Now here the carriage return doesn't show anything, but the character really is embedded within our string. Most common though, you'll actually combine these to form what's called a carriage return line feed, a character that's often embedded in text files. The tab is also supported as an escape sequence by using a backtick T. And here we get space cite. Now you may ask yourself, what if I want to embed a really long block of text within a string? For that, here strings were invented. To define a here string, you declare your variable, and at the end of the line you put an @ symbol followed by a quotation mark. I then have some text, some more text, and a bit more text. I can even insert blank lines. When I want to end my here string, I go down to the next line and I put the quotation mark and then an @ symbol to close it out. Now, that syntax is very important. To start the here string, the @ quote mark must be the last character on a line, and then everything starting on the next line and going all the way down is in the here string until it hits the double quote @, which must be the first characters on the line. If I were to put this at the end of the line here, it would not work. So let's watch this defined. And we'll run that, so we've got it defined. Now, when I want to display it, I get my here text output correctly. It also works using single quote defined strings. Here, I have some more here text, which I'm going to define. And I'll run this. And it's now defined, and you'll notice that I have the word lets in here. and I didn't need to use the double quotations. Here, I run it, and there you go. You see that the lets is properly quoted with its single quote mark. So any quotation marks within the context of a here string are ignored. PowerShell also supports the concept of string interpolation. Simply put, this means that if PowerShell is evaluating a string and it finds the name of a variable within that string, it will replace the name of the variable with the value of the variable. Here I've set my location to my PowerShell sample directory, and then I've used variables to get the number of items in that folder as well as returning its location. So I'll execute those, and I now have those variables loaded. Now when I run this string, instead of displaying $items, it replaces that with an 11, and it replaces the $loc with my C:PS folder name. If I actually want to display the true variable name, I have to use a backtick, which is another escape sequence, within my string. And here you can see I do display $items and $loc. You should note that string interpolation only works with double quotes. Here I put my string in single quotes, and it doesn't work. String interpolation does work with here strings. Here I'm defining a here string, and within it I have items and then a tab in my folder, so I form a little header, and then down below I have my variables, and then finally I close up my here string with a quote at. So we'll assign that, and now when we actually go display it, I get my nicely formatted number of items and what folder they're in. We can also use expressions within our strings. However, they need to be wrapped up with a $, left paren, right paren, in order for PowerShell to force the evaluation. So here, let's go ahead and clear the screen. And then I'm going to replace what I had before, the variable names, with the actual commandlets that I needed to get that data. So here I have $, left paren, right paren, my getChildItem commandlet, and I'm returning the count from it. And then likewise at the end of my string I have a getLocation. And there we go, I get the same results of 11 items in my folder. We can also use this to do calculations. Here I've got my $ parenthesis, and inside I have it calculating the 15% of $33.33, and it returns me the result of 4.9995. PowerShell also supports string formatting, much like you find in many C-based languages. With string formatting, you use a placeholder in the place of a variable, and then at the end of the string you pass in one or more variables you want to replace. Here we're using the squiggly bracket, 0, squiggly bracket as our placeholder, and we only have one item, the number of items. The string : format means I'm calling the static method format off of the string type within .NET. And you can see I have 11 items. Now PowerShell provides some nice shortcuts for us. I can simply put these are the placeholder of 0 items, and then I can pass in a -f, which means this is a formatted string, and I pass in the variable. And there we go, I have 11 items. Now, if we have more than one variable we want to format, we simply include those as additional placeholders within my string, and we increment the number to indicate the placeholder. So 0 is the first placeholder, 1 is the second, and so forth. These correspond to the positions in which you pass the variables in. So $items is the first one I pass in, therefore it goes into the squiggly 0, and $loc goes into the squiggly 1. As before, this also works with calculations. Here I'm taking the 20% tip of $33.33, and I'm going to replace it within my string. And here I get that my tip is $6.666. Now we may want to format that to make it a little more pleasing to the eye, so we can also provide additional formatting. After the placeholder is 0, we place a colon, and then 0.00, which is an indication we want one character to the left of the decimal and two to the right. And here I get $6.67. PowerShell also supports the use of wildcards when doing string comparisons. In order to do a string comparison, you can use the like operator. So here I have Pluralsight, which I'm going to see if it's like plural with an asterisk at the end. Asterisk simply means any number of characters after the word plural will result in a match. And sure enough, these do match. However, when I compare it to the word arcane with an asterisk, it returns false because those aren't alike. PowerShell also supports the traditional question mark as a single character placeholder. Here we can see it's true because it matches with any character being the first character. PowerShell also supports range matching. Here I'm comparing it to plural, then any number of characters of any type, and then the last character of the string has to end in the range of S through V. Well, because T is between S and V, I get a true. However, when I run this, I get false because T is not between A and C. PowerShell also supports the use of regular expressions in doing matching. Here I have a string of Pluralsight's phone number, and that really is Pluralsight's phone number, 888-368-1240. And it's going to match to see if it matches the pattern defined in the regular expression on the right. If you're not familiar with regular expressions, this very simple one will take any character in the range of 0 through 9, and it expects 3 of them as defined by the squiggly braces. I then have a dash, which means it's just a literal character of a dash. I then repeat it. The brackets indicate any number in a range of 0 through 9, 3 more, and then repeat at the end with 4. So when I run this, I get true because it does match that pattern. The second line does not match because ZZZ is not a character in the range of 0 through 9. Finally, you might think this last one would match, but it doesn't because a period is not the same thing as a dash. Hence, I don't get a match. Arrays in PowerShell are extremely simple and flexible. To assign an array, you can simply list all of the items you want in there separated by commas. Here I've assigned a couple of values. If I want to get one of those values out, I use a traditional indexing syntax where I pass in a number that indicates the position in the array within brackets. All arrays in PowerShell are zero-based. This means the very first element in the array will be at position 0. And here I've returned that, and we'll do the second position, which is 1. If I want to display all of the values in my array, I simply run that, and I get everything. Let's go see what data type an array is. In .NET parlance, it is an object. Now the brackets after the word object indicate this is an array of objects. Arrays are also easy to update. Here, I'm simply going to assign a whole new set of values to my array. And I'll just plug my name in there. Then when I display them, you can see they're listed on each item. Now let's say I want to replace that with other values, say plural for position 0. I can run that, and I've now replaced it. And if I go print the contents of the array, there you can see I've now replaced the first element. And let's replace the second element, and then we'll print it out. And there we go, there's our new array having been updated. There is a formal array creation syntax, and that is to use an @ symbol followed by a paren, the values, and then another paren. So here I'm going to assign these values and then print them out, and that worked fine. Now the reason I mention the formal creation syntax is because if you want to create an empty array for some reason, then the only way you can do that is by using the formal array creation syntax, which is simply the @ symbol, and then we'll just not put anything inside of our parenthesis to indicate that this is an empty array. And if I want to display how many values in there, I get 0, indicating it's an empty array. PowerShell also has a cool shortcut syntax for loading in a range of numeric values. It is to put the first value followed by 2 periods and then the last value. So here I'm going to load the values of 1 through 5 into this array variable, and then we'll print it out. And I get the values 1, 2, 3, 4, 5. Another common thing to do is to check to see if an item exists within our array. Here I'm going to create an array called numbers, and I'm going to load 3 values into it, 1, 42, and 256. I then want to see if the number 42 exists in this array. Well, to do that, I use the dash contains. After the contains, I then simply pass in the value that I want to see if exists. And sure enough, 42 does exist as a value within our array. I can also check to see if values are not in the array by using the not contains. When I do so, I run it, and it tells me, sure enough, 99 is not in my numbers array. Now, using not contains can get kind of confusing sometimes, because here I'm going to check to see if a value, in this case 42, is not in the array. When I run this, it tells me false, that this value is in the array. So the double negative syntax can get pretty confusing. For that reason, I suggest you stick to just using contains. In addition to arrays, PowerShell has another method for holding lists of values called hash tables. In an array, you use an index that is numerically based to go look up a particular position within the array and then return a value. With hash tables, a string-based key is used to go get the value for that particular key. Here you can see I'm defining a hash table by using the @ symbol followed by a squiggly brace. I'm defining 3 values for my hash table. The first is key with a value of value. Then I have Pluralsight with pluralsight.com as the value. And then arcane code with arcanecode.com for the value. I've separated these key value pairs with semicolons. So let's load this up. Then let's go print out its value. You can see here I have my keys on the left and values on the right. Now if I want to return the value for a single key, I can enclose that within the brackets just as I would for an array, but instead of a number, I'm going to pass in the key. So here I'm returning Pluralsight's web address by passing in the Pluralsight key. I can also use an object type syntax to get to my values. So here I'm using Pluralsight key after a period, and I also get the same value back of pluralsight.com. I can also use variables for my keys. So here you can see I'm assigning the value Pluralsight to a variable named myKey. I can use the object syntax and return the value. I can also enclose that expression, and here I can actually have an expression which I'm defining as plural plus sight as a string, and I am forcing it to be an expression by using my $sign parenthesis. Remember that from earlier in our string handling discussion. And there we go, pluralsight.com. Adding and removing values is pretty straightforward. Here I'm going to display what's in there right now. There's my 3 keys and my 3 values. I'm now going to add a new value. To do so, I'm going to enclose that within brackets to have the new key, and then I'm going to assign its value on the right. Now that I've assigned it, I can go retrieve it, and now you can see I've added a new value to my key list pair for the $sign hash table. To removing it, I simply use the remove command, $sign hash.remove, and I pass in the key I want to remove. And there I've just removed arcane code, and I'll run this, and now I get 3 new key values with the arcane code when removed. Seeing if a key exists is a pretty common thing. You often will want to see it before you add it or remove it, for example. So to do that, we simply use the contains method off the hash table. So here, it should be there, and sure enough it is. And now let's see if the one that I just removed is still there, and it returns false because it's not. I can see if a value exists by using the contains value method. So here I'm going to see if the pluralsight.com value is there, and sure enough it is there within my hash table. And then we'll see if this one's there, And nope, it's false because I did just remove it. I can also get a complete list of my keys and my values by simply calling the keys or the values method. Here I've called the keys and it lists all my keys, and I'll use .hash.values, and there they are. I can also search to see if a key or value is already present within my hash table. You can see I can use the contains keyword. I pass contains and then the name of the key I'm looking for to the .keys method for my $hash, and sure enough it tells me it's there. I can also do the same thing with values by passing -contains and the value I'm looking for into my .values method. There it is, true enough, it's there. In addition to being able to create your own variables, PowerShell has a list of built-in variables. It's quite a long list, but we're just going to take a look at a couple of the more useful ones that we can start using right away. The first two are false and true. If I just print these out, you see I get a simple false or a simple true back. These are useful for doing comparisons to see if the result of some logical comparison comes out to be false or true. It makes it a lot clearer than using a 0 or a 1. There's also a placeholder for null. Of course, it doesn't display anything to us, but again, it can be used in doing comparisons. Another useful one is pwd, which prints out the current working directory. And here we go, I'm in my demos directory. I can also see what my home directory is. I can find out a lot of information about my particular PC. And it shows what version of the PowerShell I'm running, my instance ID, my UI, things like that. I can also find out what the process ID is for the interface that I'm currently running. And there we go, right now it happens to be 2712. We can also find out information about the current version of PowerShell. There we go. One of the most useful ones, though, is the variable that holds the current object. Here I'm piping getChildItem through the where object. Now what this is actually passing in is a collection. The $underbar allows me to iterate through each item in the collection and points to the current item. So what's going to happen is getChildItem is going to pass in its collection to where object. Where object is going to iterate over my collection of child items, which in this case are the files in my current folder, and then for each one of those I can retrieve the .name property off the current object, and if it's like PS1, it's going to print it out. So there's just a few of the useful built-in variables that PowerShell has. As we move through the lessons, we'll be taking a look at a few others as they become relevant. By now, you should have a firm understanding of PowerShell variables. Your knowledge of the star variable commandlets gives you a good insight into how PowerShell works with variables under the hood. You should know all about strings and the power they hold. You've mastered collections, both in the form of arrays and hash tables. Finally, you saw a few of PowerShell's built-in variables, which you can use to enhance your own applications. Thanks for watching.